What's up? It's Ms. Rankin. I'm going to talk to you today about the Polygons test review. All right, so let's jump right in. Number one says, how many triangles can an n-sided polygon be sectioned into? If you remember, we talked about the fact that a polygon has the number of triangles in a polygon is 2 less than the number of sides. All right, so any polygon, say it has 100 sides, it's going to have 98 triangles. Has 5 sides, it's going to have 3 triangles. All right, what's the formula to find the sum of the measures of the interior angle? So the sum is the number of triangles times 180, excuse me. So to find the number of triangles, we do n minus 2, and then we multiply it by 180. All right, one interior angle is the sum divided by number of sides. Okay. Find what is the formula to find one exterior angle? Remember, the sum of the exterior angles in any polygon is 360. So to find one of those, we divide it by the number of sides. Divide 360 by the number of sides. All right. The measure, this says give a counterexample. A counterexample is something that disproves it. All right, so you want to keep the first part true and make the last part something that disproves it false. So give a counterexample to the measure of each exterior angle of any regular polygon is always a multiple of 10. All right, so I need to find where an exterior angle is not a multiple of 10. So I'm going to go to my calculator where I have put in my equations into my y1, y2, and y3. In my y3, I put 360 divided by n. So these are my exterior angles. 180 is a multiple of 10, 120 is a multiple of 10, 90 is a multiple of 10, 72, not a multiple of 10. So a pentagon, a 5-sided figure, is not a multiple of 10, and so you can just say the measure of an exterior angle of a polygon, sorry, not polygon, pentagon, is 72. Excuse me. Since 72 is not a multiple of 10, that disproves your statement, so you've come up with a counterexample. Right? The sum of one interior and one exterior angle of a regular polygon equals always 180 degrees because the angles form a linear pair. Right? Okay, this says if each exterior angle of a regular polygon is 60, how many sides does the polygon have? I'm going to go to my calculator where I have my chart, and I'm going to look for where y3, because that's where I put my exterior angle formula, is 60. And here we go. It's right here. A hexagon. All right. What is true about the interior angles of a non-regular nonagon? Okay. For the sum of the interior angles, it doesn't matter if it's regular or not, meaning they don't have to all be congruent to each other. They still have the same sum as a regular figure. So we just need to find out what the interior angles of a nonagon equal. All right, a nonagon is a 9-sided figure, and the sum of its interior angles is 1260. What is the sum of the measures of the interior angles of a 21-gon? I have no idea. And also, I don't want to hold my down arrow till I get to 21, so I'm going to go to second table set, and I'm going to tell my table to start at 21. Here I am at 21. That's 3420. All right. A non-regular pentagon has 5 exterior angle measures of 45, 53, 42, and 52. What is the measure of the 5th exterior angle? All right, well, we know that the sum of the exterior angles in any polygon is 360. So I know that 45 plus 53 plus 42 plus 52 plus that last one, x, is equal to 360. All right, so I'm just going to use my calculator here. And I'm going to go back to my screen. And I'm going to say 45 plus 53 plus 42. And then 52. And I need to do 360 minus 168. So that last angle is 168. Excuse me. In a regular polygon, all interior angles are congruent. That's true. That's what makes it regular, is that all the angles are congruent. Okay. Number 1 here, the property goes, so the property here is that consecutive angles, that means one right after the other, consecutive angles on the same leg are supplementary. So I know that 9x minus 20 plus 5x plus 4 equals 180. And I'm going to go ahead and solve for x. So that's 14x minus 16 equals 180. I just combined like terms. Now I'm going to move that 16 by adding it because it's a negative. So now I have 14x equals 196. And then I'm going to see what, I've got to move that 14. I do that by dividing. So I do 196 divided by 14. And you get 14. All right. And so x equals 14. Let me make sure I answered my question. It says solve for x. That's what I did, so it's done. All right. Now, the mid-segment is equal to 15 plus 31 divided by 2. This mid-segment is equal to the bases divided by 2. So I'm going to say 2 times 15 plus 31 equals 5x plus 3. Not 2 times. Divided by. My bad. I wrote it the wrong way. The mid-segment is equal to the sum of the bases divided by 2. So 15 plus 31 divided by 2. What's that? 46 divided by 2 equals 5x plus 3. So that's what? 23 equals 5x plus 3. I move the 3 by subtracting it, so I have 20 equals 5x. I move the 5 by dividing, so I have x equals 4. Make sure that I that I answered the question. The question asked me to solve for x, so I'm good. All right. It says graph it first. Whenever they give you a hint on a test, you should take the hint. I'm going to get some graph paper so we can do that. Okay, so I went ahead and graphed it. Here's my 0, 0 right here. All right. And it wants an isosceles trapezoid, which means I need the legs to be congruent. So I see that this leg, to get from here to here, I go down 1, 2, and over 2. So I'm going to do the same thing over here. I'm going to go down 2 and over 2 to find my point M so that I have congruent legs. All right, so M is at 1, 2, 3, 4, 1, 2. All right. Number 4 says solve for x. We're going to skip that one. I could do it, but in our L-level classes, I don't think we've learned how to deal with x squared. All right, what's the length of the mid-segment? Remember that the mid-segment is half of the sum of the bases. So 50 plus 10 is 60, divided by 2 is 30. All right, if PQ is 10, what's PS? We'll come back to that one. I don't think that's something we're dealing with again in my L-level classes. All right, number 7, label all the congruent angles and sides, parallel lines, and supplementary angles on the isosceles trapezoid below. All right, so I know that, let's look at our trapezoid properties. All right, isosceles trapezoids. Non-parallel sides are congruent. So that would be these two. All right, what else do we have? The diagonals are congruent. They didn't draw diagonals, so we don't need to label them. Base angles are congruent. Just like in the base angles of a isosceles triangle. So these two angles are congruent. Opposite angles are supplementary. So angle D plus angle B equals, supplementary means 180. These angles are opposite each other. Angle C plus angle A is 180. These angles are opposite each other. All right. Let's see. I think we can stop there. Yeah, we'll stop there. A and B are also going to be congruent. That's enough. Let's stop there. Okay, number 10. Which location of D would make the polygon a trapezoid? All right, it doesn't say that it has to be an isosceles trapezoid, just a trapezoid, which means that that BC has to be parallel to AD. So D needs to be anywhere on this x-axis, meaning that the y value needs to be 0, but that doesn't seem to be an option. Let's see what's going on. 9, 4. Oh, they're really trying to trick you here. 6, 3. 6, 2. Let's see what's happening. And 7, 3. So what you need to find out is they're trying for this to be one of the sides, not one of the bases, meaning they want your other side to be parallel to AB. So let me pause it and plot those points, and then we'll look at which one makes them parallel. Okay, so when I started this problem, I thought that this was one of the bases, meaning I thought I was looking for the other point to be here, to be parallel to BC, but that's not true. This is actually the base, so my other point needs to fall on this line, which is parallel to AB. So what I did was I figured out that the slope of AB, I went up 8 over 4, so my slope of AB is 2. So I started at C and I gave CD, which I don't know where D is yet, but I gave CD a slope of 2. I went down 2, left 1. That's the same as going up 2, right 1. So I gave CD a slope of 2, and I know that D has to fall on this line. So 9, 4, that's not on the line. 6, 1, 2, 3, that's not on the line. 6, 2, that is right here on my line. So that's D. Okay. 7, 3. Is also not on the line, so yeah, it's definitely 6, 2. All right. And then for number 11, for the kite, it wants me to label all congruent angles and sides on the kite below. So let's look at our kite properties. All right. I know that, can't find my kite properties. Okay. I know that it has exactly 2 pairs of congruent sides, which are here and here and here and here. All right, label all congruent angles and sides on the kite below. 1 pair of opposite angles are congruent. That's the pair that end up on top of each other when you fold along this line of symmetry here. Remember, each kite has 1 line of symmetry. The diagonals are perpendicular. I don't have those drawn in, but if I had a diagonal, this would be a right angle. All right, so we're going to stop there. Good luck on your test tomorrow. I realized I accidentally skipped number 8. So NK is 7x minus 1. NM is 10x minus 13. And KM is 24. Find NP. Okay, so what I'm going to do is I'm going to work on getting a right triangle here, okay? So I can use Pythagorean theorem. If Km is 24, then I know this is 12, all right? So I need to solve for x and figure out what this is. I know that these 2 sides are congruent, so I'm going to say 7x minus 1 equals 10x minus 13. I'm going to move the 1, no, I'm going to move the 7 because it keeps things positive. So negative 1 is 3x minus 13. Then I'm going to move the 13 to the other side. So that gives me 12 is equal to 3x, which means x is equal to 4. So now if I plug this in, 7 times 4 minus 1, what's 7 times 4? 28. Yeah, 28 minus 1, that gives me 27. So this is 27. So I'm going to do c squared minus a squared. So I'm going to go 27 squared minus 12 squared. 27 squared minus 12 squared. 24.2. That's my answer. This MP is 24.2. Yeah, and that's what it asks for, NP. So what I did here was I solved for x so that I could find this side length so that I could use Pythagorean theorem to find this piece of the triangle. All right, I want to come back and do number 6. So this is a 45, 45, 90 triangle because these 2 sides are congruent, and here's my right angle. So I know this is x root 2. So this is 10 root 2 here, okay? And then I have this is 60 degrees, and these 2 are congruent. That I have a equilateral triangle, so all 3 sides are the same because all of the angles in here are going to be 60 degrees. All right, so PS is then also 10 root 2. All right, and then the last one that I wanted to come back to was number 4. I know that these 2 are supplementary, so I can say x squared plus 20 plus 60 equals 180. So x squared plus 80 equals 180. If I subtract 80 from both sides, I get x squared equals 100. To undo the square, take the square root of both sides, so x is equal to 10. The question asked me to solve for x, so I'm done. Okay, I really am done with the test review this time.